Hello, good afternoon, everyone. So, as you kids remember, what we did last time is that we did two cases, right? Like in the first case, what we did is we introduced positive charge, right? And then in the next case, we introduced negative charge. And what happened in both the cases? You can remember what happened in both the cases. In both the cases, the plates they went away from each other, went or came closer. They went away from each other. In both the cases, right? So higher the charge, higher the divergence, right? And this case also same thing, higher the charge, higher the divergence, right? Higher the magnitude of charge, higher the divergence. So now let us answer some question based on what we have done already. And that is, let's say I have given some charge to the electroscope and I observe some divergence. Can you tell me which charge it is? So basically, I'm giving it some charge and I don't know whether it is positive charge or negative charge. So I'm giving it some charge. I don't know whether it is positive or negative charge, but what I'm seeing is that I'm seeing some divergence. That means the plates are going away, right? Plates are like this, they're going away from each other. They're like this close, then they're going away when I'm giving some charge. That is my observation. That is what I observe. So, can you tell me what charge has been given, positive or negative? That is what you have to find out. Whether I have given it a positive charge based on this observation. What is observation again? That I give some charge to this metal rod, right? I give some charge, and as a consequence of giving the charge, the plates go away from each other. So if they go away from each other, I have to find out what is the polarity of the charge. Polarity means plus or minus. So I have to find out what is the polarity of the charge that I've given. You know? So tell me, can you guess which charge will it be? They're going away from each other. In which case do they go away? The plates go away in which case? In case of positive charge or negative charge or both? The problem that we have here is in both the cases, if you recall, in both the cases, there is some divergence. If you give the negative charge, then also the divergence is there. And when you give positive charge, then also divergence is there. In both the cases, the plates go away. That means in both the cases, there is some divergence observed. And in this case, divergence is observed. So can I say whether it is positive charge or negative charge? So we can't say whether it is positive charge or negative charge, right? So what is the limitation of the system? The limitation is it can tell us presence of charge. It can tell me whether the charge is present or not. How can it tell? Because if there is no charge present, that means divergence will not be there, right? But if divergence is there, that means either I have given it positive charge or I have given it negative charge. So that is what the system can tell me. It can tell us presence of charge, right? Presence or absence of charge. Absence of it can tell me how. If there is no divergence in the metal sheet, that means no charge has been given, right? And I can say the charges are absent. On the other hand, if there is presence of charge, there will be divergence. So it can tell us that whether a charge, whether I have given some charge or I have not given some charge. That information it can give me. Okay? So that we know. But what it cannot tell us, now can you kids think what it cannot tell us? So I told you what it can tell us. But if I ask you what it cannot tell us, so can you tell me that? Which part it cannot tell us? But not the dash of the charge. It cannot tell us something, and not the polarity of the charge. Polarity it cannot tell us, means whether it is plus or minus, that it cannot tell us, right? Because plus also ends up giving you divergence, and negative charges also end up giving you divergence. So we cannot really decide the polarity of the charge, right? So take this down, then we'll go to the, this is the system we are studying. We are studying the concept, and then we will study the device which uses this exact concept. Take this one. Okay, so now let's go ahead and talk about the device. So this device is called gold leaf electroscope. So what is there in this device? Let us see. You can see that there is a glass box, right? You can see a glass box, and inside that is a metal rod. And attached to the metal rod are our sheets, as you can see. Right? Two sheets are attached to it. Two sheets, and those sheets will go away or it will come closer depending on whether you provide it some charge or not. You know, there is a metal knob, that is where you give the charge, let's say plus or minus charge. And to that connected is a metal rod which carries the charge, and then there is a rubber which acts as a separation between the glass inner portion and outer portion. There's a glass window we have put, Why we have put a glass window? So that air doesn't enter and it doesn't disturb the metal sheets. And then this sheet is made up of gold, right? And then we can give either positive or negative charge, and there will be some divergence, and we will say since there is some divergence, that means we have given it some charge. That means the charges are present, right? That means some charges have been given to the metal node. We can find that out if there is some divergence. Now, why do we use gold? What is the reason of using gold? It's a very expensive metal, right? So the reason for using gold is that it is both malleable and ductile, okay? So that it doesn't break. When you make a sheet out of it, it doesn't break, right? And you can make a sheet out of it. That is why we have chosen gold, because if we take some other element, we might not be able to make a sheet out of it, right? And if we bend it, it might break. So that it doesn't break and we can make a sheet out of it. This property is called malleable and ductile. So gold has both the properties, and on top of that, it is also a very good conductor. So those are the reasons that we choose gold. So you can draw the diagram, write the heading, and then we'll move forward. And do write it down. Do make notes. Otherwise, you'll not understand. So, right now it is easy, but slowly things will become difficult, right? So if you're not making systematic notes, very soon you will find yourself in a difficult position. Please make a note. Please utilize this time that we give in between slides to make up your notes. Make both the diagrams. Okay, so let's move ahead from here. Now let us see what are conductors. So conductors are the material or substance which dash electricity to flow, which allow or don't allow, which allow electricity to flow through them, right? That's what conductors are. They conduct electricity as we know it, right? They conduct electricity because they they have free electrons. Electrons are free to move inside a conductor, to flow easily inside them from one atom to another atom. What are the examples of conductors, guys? So the most we just saw an example, right? Which is the best example we just saw? Gold, of course. Then you have iron, right? What else, guys? Aluminium, right? And so on. Are humans a good conductor of electricity? Do we also conduct electricity, kids? Do our bodies conduct electricity? The answer is yes. That is the reason we feel shock, right? Shock. What happens in shock? The electricity, it goes through our hand to our body and into the ground. So current flows through our body. So if current is flowing through our body, that means our body is a good conductor of electricity, right? And that is the reason we feel shock. If we were a bad conductor of electricity, it would have been so nice, right? It would have been a perfect world in which I wouldn't feel shock due to the current. But alas, that is not the reality, right? Let's go ahead. Okay, take this down. Then we'll go ahead. Alright kids, so let's go ahead. Conductors done. Now let's go to insulators. So insulators, as the name suggests, it insulates, right? It impedes the motion of free electrons and thereby not helping the current to flow. So an insulator is a material that does not conduct electric current. Example, there's so many examples, right? Like rubber. Can you give me some examples of insulator that doesn't conduct electricity? Think of anything that comes to your mind. There's so many examples in the world which does. Plastic, very good. What about online kids? Can you cite some examples? Any more examples? What about wood? Yes. What about clay? That depends whether it is wet or not. Right, so we'll not take a contentious example. Let's take a simpler example. What else? What about vacuum? Is it a good insulator? Yes. Current doesn't flow through vacuum, right? It's blank. There's nothing there. And current needs something to flow through, right? So vacuum doesn't have. So we can take down this example. You don't have a copy, but you can get these lectures anyway. You know. That I don't know that. Okay, someone asked me yesterday to introduce myself because I still haven't introduced myself, and in the rush of things, I just skipped this part. Just got skipped. Okay, so well, uh, I'll be teaching you physics, and my name is Afzal. I've done my masters of technology in aerospace engineering from IIT Kanpur, and before this I worked in Bansal classes in Boeing as a research engineer and in Akash Institute. Right, so that's about me. Let's carry on. What will happen if we bring, so now let us see what is induction. So what is this phenomena called induction? See guys, let us say you have a metallic object, right? You have a metallic object. This is before introduction of the rod. I mean, there's what do you mean by rod? I'll tell you later on. But right now, just think of a metallic object. So, what is the net charge of metallic object? It is electrically neutral. Neutral means there is no charge. You know, no charge, but actually it has charge. How it has charge? Because every object is made up of atoms, and atoms have nucleus, and nucleus have protons and electrons. So it does have charge. Not that it doesn't, right? It very well does have charge. So it has got positive charge, and it has got negative charge. Right? And that is why it is neutral, right? As many positive charges as many negative charges are there. Now, what is going to happen if I slowly introduce a rod, and that too a rod having what charge? Positive charge. After the introduction of the rod, which has got positive charge, so what will happen, guys? Now I know my object is but made up of positive and negative charges, right? So what will happen when I introduce this rod? Now rod being positively charged is going to attract what? Which charge? Negative charge, right? So the negative charges will get attracted by the rod. And positive charges, because they are like charges, they will get repelled from the rod. So they will go and accumulate here. Is my conductor still neutral? Is my question. Is the conductor still neutral? Yes. But the charges got redistributed. And this phenomena is called, this, this phenomena is only called what? Induction. Understood? Right? Just redistribution of charges due to a presence of some other charge in a conducting object is called induction. So redistribution of charge due to external influence of other charges is called induction. Right? Makes sense? That's what we have written here. Now, online kids, you can note this down, and next time you get your copy, right? It will help you understand better. Even if it is a small duration you're attending for, whatever you're attending, at least it should be fruitful, no? Whatever you're still spending some time, make use of that time. So, online kids, take this down. Now we're going to see another method of induction, right? And let's see what it is. This is actually mentioned in your school books, NCERT book. So what do we do is that we have two spheres as you can see, right? Sphere A and sphere B. And we are bringing up positive charge. They are both in contact with each other. Then we bring positive charge. And what is positive charge going to do? Tell me. It is going to get which charges here? Negative. And the see, this is neutral, right? Neutral means it has got negative also and positive also, right? And but because of the positive charge that I've got, it is going to attract all the negatives and it's going to repel all the which charge? Which charge will get repelled? Negative charge will get repelled. This is positive charge. Positive charge is going to attract negative charge or repel? Attract. So what is it going to do to the positive charges? The rod will attract positive charges or repel? Repel. So positive charge will repel means the positive charge of this object will go on which sphere? A sphere or B sphere? Very good. Now we separate the two spheres. You see we have separated, you know. Sit here, I can see you more easily, that bench. Yeah. Now I'm going to separate the two spheres, you know. So if I separate the two spheres while the rod is still there, and in its influence I've separated. So what will happen? This negative charge that it got will remain on this object only, you know, and that positive charge will is remain on this, and they're trapped because they can't go anywhere. Have generated a separation between them. Got it, no? So those negative positive can't run away anywhere, you know. And now what I'll do? My objective of a rod is complete. Now I'll take it away, and I take it away, and now I end up getting, as you can see, end up getting two spheres, one having negative and one having positive, right? And then I can separate them also properly. I get negative and positive. You know, to see how I generated negative and positive charge without really touching anything, right? I just had two simple neutral spheres, and I just did some process, and I ended up without touching. I ended up getting one sphere having full negative charge, one sphere having full positive charge. Got it? So this is another process of induction. Right? So we can take this down. Then we'll go ahead. Is this clear, this process? Online kids, take this down. Once you've written this, I'll move to next slide, copy that also, then we'll go ahead. Where did you study lemons from? Very hectic schedule, no? Yeah. Very hectic schedule, no? Right? Hectic schedule. Right? How the teaching back? Is it good? Yeah. Great. No, it's not good. That's right. Oh, they're just asking to memorize it. here, here you'll get only concept. The more you ask, the more you'll understand. So other students, they want to mug up there, or they also want to understand? They want to mug up. Others are happy with that. But with mugging up, you can't clear IIT. If to get into IIT, you have to have basic fundamental understanding of it. You know, because the thing is, most of the questions asked in IIT, they are not difficult questions. Most of the questions are not difficult, right? Most of the questions are actually. See, I'll tell you the breakup of questions in IIT. Let's say there are 100 questions in IIT. Out of 100 questions, let's say there will be 35 to 40%, 35% easy questions will be there, you know. So that you can do, you can easily do it. Then there will be 40% questions that will be medium level, 35% easy, 40% medium level, right? So how much we have got? 75%. And then rest 25% will be difficult questions, right? Difficult questions will also be there, and that will be next the rest 25%. So in total we have got how many questions then? 100% questions, right? So in 100% question, of course, we have 35% easy, 40% medium, and rest 25% hard, you know. So now you might think that it is so easy to clear IIT, right? Because it's only 35 easy and 40 medium and 25 difficult. You know, this is the average averaged over entire. Of course, it changes year to year, but I'm telling you averaged over the entire years, right? So I've been teaching since 2010. So and of course I've gone through papers before that also, and I'm telling you the average over all the years, you know. So, and you know how much you have to attempt to get into IIT, how much percentage of you have to get into IIT? Is 50% good? 50% is more than sufficient to get. If you just get 50%, no, 50% marks, you can get around 2000 rank in IIT, right? Just 50% also. So it is very easy to get, because 35 and 40 means what? 75%. You should be able to do, right? So everybody should be getting a good rank or a good marks at least. But why don't students still get it? Even despite of paper being easy and medium mostly, why don't students get good marks? You know why? What is the reason? This is very essential part and should be told before every IIT, to every IIT aspirant, that what is the difficulty about IIT is, despite of the fact that most of the questions are easy and medium, the problem is that even though the questions are easy and medium, these are new questions. Questions that you have not seen before, you have not practiced before, questions whose formulas you have not mugged before. Understood? So that is why, despite the questions being easy and medium, these are new questions and you have to think from the scratch. And to be able to think from the scratch, you have to understand the subject from the scratch, right? You have to have a holistic understanding of the subject, right? Through and through, grassroots level, visceral understanding of the subject is required. Superficial knowledge and formula memorization will not work out here, right? All right, let's go ahead. It's done. Now, let's take this example, and then I'm giving you some example, and I'm not telling you which topic is it, not yet. I'll introduce the topic after I've given you the concept of the topic, right? So let's see, you have hair and you have comb. Have you done this experiment, like rubbing the hair on the comb? Then after rubbing the comb on the hair, we get this. What do we get? My comb get which charge? Negative charge. Whereas my hair get positive charge. Right? Now if I ask you, see, earlier when I introduced the comb, it was neutral. It didn't have any charge. This was also neutral. right? But after rubbing it on the hair, it got negative charge, right? So which charge got transferred from one object to other object? Which charge can it be? Can it be positive charge or negative charge? Which charge got transferred? Negative, because electrons have negative charge, right? And electrons can travel. Can positive charges travel? No, because they are in the nucleus, right? They can't travel. So very good. What's your name again? Bhargav. Can I just call you Bhargav? Is that fine? Bhargav? Okay. So, so it is a negative charge that travel, right, Bhargav? Okay. That means which object got the electrons? Can you tell me? Which object received the electrons? Comb. So my question is, which object is more strongly bonded with their electrons? Comb, because my hair actually lost the electrons, and that lost electrons went into the comb. That means naturally, who is more strongly related to their electrons? The comb, right? Whereas my hair are weakly bounded to their electrons. That is why those those poor guys ended up losing their electrons, right? Whereas comb ended up gaining electrons. Understood? So take this down. If you have any doubt in what you have already studied, like you're saying, no, you couldn't understand because they're just giving you formulas and all. So if you have any fundamental understanding, especially I think in mechanics, you will have difficulty, right? So if you have any doubts also, you can ask me now, right? To see the difference and the level of detailed explanation, right? And then you can decide for yourself. So after this, you can ask me anything, any doubt that you have. Any question also, whatever it is, just get it. Fine. So let's go ahead. This time we have some time. Take this down, honest students. Better to attend here only. Come here and that will be better. It's better than online. No, it's more engaging, I suppose, isn't it? But get a copy next time. Hmm. All right, let's go ahead, kids. Now, in friction, when two bodies are rubbed together, electrons are transferred from one body to another. Right? It should be in charging by friction. In charging by friction, when two bodies are rubbed together, electrons are transferred from one body to another body, like we saw here. When we rubbed two bodies, electron got transferred from one body to another body, right? And that process is called charging by friction. Right? As a result of this, one body becomes positive charged while other body becomes negatively charged. Example, another example, when a glass rod is rubbed with silk, the rod becomes positively charged while the silk becomes negatively charged. So silk is getting negative charge, guys, and rod is and and and, and rod is getting positive charge. So dash is better bonded with their electrons. Who is better bonded? Silk, because silk end up getting the negative charge. However, ebonite on rubbing with wool becomes negative charge. So ebonite gets negative charge and wool gets positive charge. Dash is better bonded with their electrons. Ebonite. Clouds also become charged by friction. Right? Friction is the reason by which they get charged. In charging by friction, in accordance with conservation of charge, charge gets conserved. Both positive and negative charges are in equal amounts and appear simultaneously due to transfer of electron from one body to another body. Make sense? So online kids, you can take this down, and I think times by the time you would have taken it down, time would be up. So you can take this down, and then we can close it. And if you have any doubt, you can ask me. Understood now? Yeah. So I think next time onwards, we should be starting with Coulomb's law, I suppose. Yes. And this is from where actual physics will start. 12th physics will start with Coulomb's law. Till now, it was just theoretical part, and mostly you knew it already, right? This basic things you studied in junior classes. So next time onward, kids, we'll be starting with actual physics of charges with Coulomb's law. And we'll get into the equations, and that's the real deal. So any doubts you have, you can ask, or any query if you want to have. Question practice. We'll be doing questions also. Questions are also there in that. So first there'll be theory, and then there'll be questions. Like till now there was no question we could do because it was we are studying theory only, right? So now once the students have taken it down, I'll show you. You can come here. I can show you. Come here. So like I'll show you one of the PPTs. Bridge course means these students for 11th class. For them, you see this first theory, all theory, and then one question is there based on that. Then angle between vectors, and then there are questions based on that. You have to find the angles here. Then you have another question. Then you have another topic, and based on what is the topic? Multiplication of vectors by positive number, negative number, you know. And then based on that, there is another question exactly based on that topic. You see, the question is there. You know? That all comes how we arrange it. We have vector addition of vectors, and then formulas and all are given, derivation is given, then question based on exactly that part. Got it? So that is how it will appear here also, how we arrange it. The question should be done after the theory, right? First you have to have question, theory, and that two questions based on the theory that we have studied till now, not the entire theory, right? That's anything else? No, so you can carry on then because class is anyway over. You know, if you have anything, ask me, or we can carry on because class is done. Okay. Huh. Because electrostatic repulsion will be there because between positive and positive charges, right? And they're so close to each other that they'll want to destroy the nucleus, right, and break it apart, but it still doesn't break. So how many fundamental forces do we know? We know there's gravitational force. Fundamental forces of nature. What are the fundamental forces of nature? One is gravitational force. Gravitational force is attractive force. So maybe that can keep them together, but the value of gravitational force is much less than electrical force. Electrical force is 100 times stronger than gravitational force, right? So it is not the gravitational force that is keeping them together. While the electrostatic repulsion is there, gravitational force is not keeping them together. Then there is something called strong nuclear force, whose range is around 10 to the power minus 15 meter. So that range works within the nucleus itself. That range is so small it works within the nucleus itself. That keeps the all the nucleons together, and it is that force is independent of the charge. So that acts between neutrons and neutrons also. Neutron, proton, everybody it makes sure that the structural integrity of the nucleus is not compromised. That strong nuclear force ensures that. And since the range is small, it cannot act all the way to electrons. So it doesn't pull down the electron to the nucleus. If it does, the nuclear atom will be destroyed, right? But strong nuclear force are very strong, but in short ranges, and that is what keeps the nucleus together, despite the electrostatic force, because strong nuclear force, as the name suggests, are the strongest forces in nature. But a strong nuclear force, yeah, that's it.